All right, so I recognize I'm the one expected to bring the energy up after lunch and after that riveting presentation from the Rally Triangle. So this afternoon, this is going to be a conversation about space, the final frontier. And I have some brilliant minds that have been working on our spaceport here in Virginia, and I'll introduce them in a second. As you all may know, Virginia's Eastern Shore is becoming a hub for aerospace activities, a spaceport, with the Virginia Spaceport Authority's Mid-Atlantic Regional Spaceport, MARS, and Rocket Lab's orbital vehicle launches, all based here. Additionally, we have NASA's Langley Research Center that conducts research in various areas, including supporting human and robotic exploration of deep space. For those who may not know, it was also the workplace of 3 Black female mathematicians featured in the movie Hidden Figures. And if you haven't seen Hidden Figures yet, see me after class, please. Now, here with us today are 3 really brilliant folks. I've watched their webinars. I've researched their talks several times. I can tell you, I still don't quite get it, but I know that they're, and that's on me, it's not on them. But they represent our efforts in this area. And so today, you're going to hear from first Sean Mulligan, COO and Deputy Executive Director of Virginia Spaceport Authority. Sean, do you want to raise your hand? Wave. There you go. You're also going to hear from Aaron Kuipers with Rocket Lab. And you're going to hear, too, from NASA Langley, Don Schaible. Don? Okay. I'll introduce each area first, and then we'll get into a conversation, because I know each of you have presentations. So the Spaceport Authority. Virginia has invested in the Spaceport Authority and the Spaceport specialty infrastructure in the last 2 decades. Virginia's Spaceport Authority's Mid-Atlantic Regional Spaceport, MARS, not to be confused with the planet Mars, with its 3 launch pads and a 4th pad in construction, is one of only 4 spaceports in the United States that's licensed by the FAA. MARS, again, their system, is the only U.S. launch site on the East Coast. I'm not sure if you all were aware, but there are 2 launch sites on the East Coast, Cape Canaveral, and we're the 2nd. And they're capable of launching mid-inclination orbits critical to the Department of Defense, intelligence community, and NASA. So that makes it an alternate site for missions of national importance, particularly in support of national security and human spaceflight. And as I understand it, Sean, you've said we do International Space Station resupply missions very well. Is that correct?
I may have said that.
Okay, you may have said that. Cool.
It's true.
And it's true. Moving on to Rocket Lab. Now, Rocket Lab is a California-based aerospace company. We will not hold that against them. And since 2023, they have successfully launched 4 Electron missions from Pad 0C and its Launch Complex 2 at Mars. I don't know what any of that means, but I know you're going to educate us. 3 of those missions were orbital and 1 was suborbital. Rocket Lab has chosen our Eastern Shore as the location for launching and manufacturing its new reusable neutron rocket. Now, if that's not rocket science, I don't know what is. And then I'll move on to NASA Langley, the home of the 3 Hidden Figures. So as NASA's first field center, NASA Langley has been leading the way in advancing space technology and exploration since its establishment. Several Langley technologies have been or will be used this year as NASA explores the moon, Mars, and beyond. Now, Langley's navigation Doppler LiDAR, did I say that right, Don? Was sent to the moon, providing precise navigation data for space vehicles. The Advanced Composite Solar Sail System, ACS-3 mission, designed and built by NASA Langley, achieved a significant milestone last month when the spacecraft fully deployed its sail. Additionally, NASA Langley has been providing crucial wind tunnel data, get that, wind tunnel data, to NASA's Space Launch System rocket as part of the Artemis campaign. And so with that, I'm going to turn it over to these 3 brilliant minds to unpack for you everything that was just shared. And Sean, I believe we're starting with you. All right. You can come up here if you like. There you go. Sure. You have a clicker? Clicker's here.
Hello, everyone. My name's Sean Mulligan. I am the Chief Operating Officer and Deputy Executive Director for the Virginia Spaceport Authority. It's an exceptionally cool job, and I'm really excited to have the opportunity to join you all today and tell you a little bit about Virginia Spaceport, which if you didn't know about it before today, I hope you can take that information back and spread the word across the Commonwealth. It's a jewel, in my opinion. It's under-discussed, but it's really helping to drive the economy, especially on the Eastern Shore. So who is the Virginia Spaceport Authority? We are a political subdivision of the Commonwealth. We report administratively through transportation. John, Deputy Secretary of Transportation, is over there. Thank you for all your support. We're headquartered in Norfolk. We're actually co-located, I saw Stephen in here as well, with the Port Authority and the World Trade Center as our headquarters. But what we really do is we own and operate a spaceport up in the Eastern Shore at Wallops Island. So the vast majority of our workforce is up on the shore. And what we do is we own and operate this spaceport. We're co-located. We're a tenant organization of NASA Wallops. So NASA Langley's down here in Hampton. NASA Wallops, Virginia is one of only, I think, the only state with 2 NASA centers in it. So we are a tenant organization at NASA Wallops, but we operate very independently, commercially. We're almost like an embassy inside of this, and we've been able to build and develop complementary assets through investment from the Commonwealth to create this spaceport that I'm going to tell you about today. We are, and Nneka, thank you for referencing, we're one of only a few vertically licensed FAA spaceports, only one of 2 on the East Coast. The East Coast and West Coast don't serve all the same type of orbital regime, so it's important that we're basically a backup to Cape Canaveral and provide that capability for our country. So NASA Wallops is celebrating, I think, their 80th year. It's a long history. They've launched over 16,000 missions from there, and we have a great partnership with our landowners. This picture's from 2006. I started in the fall of 2009. I was the first engineer hired at the spaceport as the Antares program was coming on board. And this is what it looked like when I was walking around on the beach. And just fast forward to today, we're now at 4 launch pads. We're building our 4th right now. We've added additional facilities that I'll talk to you about, and we're really at an inflection point for this spaceport that's been around. We were established in 1995. We're celebrating our 30th year next year, which is really exciting. And again, it's a place for growth right now that I'll talk to about. So everyone just had lunch. I thought a little smoke and fire might wake you all up.
1, 0. Liftoff. We have liftoff of the main edition. We have liftoff of the ORS-1. It is a 1 test mission.
0 ignition.
launched 29 orbital missions from Virginia, from your Commonwealth, that, included in that wasn't all of them, but included in there, we went to the moon in 2014 with a NASA mission called LADDY. We've supplied over 130,000 pounds of supplies to the International Space Station with our partners Northrop Grumman and their Antares vehicle. Rocket Lab had their first Electron mission from Virginia. They've launched over 50 missions as one of the most prolific commercial space companies. And their first one and their U.S. home for their Electron mission is here in Virginia. Along with that, many national security missions and NASA science missions. So it's really something to celebrate. So are you seeing that chart? Okay. All right, cool. All right, so how do we do that? Right? So our Spaceport has been a strategic investment from the Commonwealth over these last 20 years specifically, and it's consistent. It shows our customers that we're committed, and it is enabling us to attract these incredible companies and all the workforce and technology development, and I'll talk about STEM that comes along with that. So this is just a timeline showing, again, this steady march of investment in the facilities and launch pads that I'll talk to. So 3 launch pads currently operating, a 4th in development. We have in our master plan additional growth for the future as well. And these are what we own and operate as a spaceport. We're a very operations-forward team. Engineers, technicians. We build these and we maintain them and make our customers choose Virginia when they're looking for a home. Not just launch pads though. We're developing outside of the federal facility as well. It's really cool to launch rockets. It's even cooler to bring the companies in that want to manufacture, integrate, and bring all the research and development that comes along with that. So to do that, you need a place for them to live and operate, integrate. So these are some examples of the facilities that we've developed over time and now enable our customers to have a place to go when they're looking for their site. Our customers, I mentioned Northrop Grumman. They were an anchor customer of ours for many years. They launched multiple different types of vehicles. Rocket Lab is a really exciting, cool company that you'll hear a lot about from Aaron. And our most recent addition was Firefly. Firefly is a U.S. space company. They have a small launch vehicle called Alpha that's going to be launching from our Pad 0A, the same facility that launches the Northrop Grumman and Terry's vehicle. So that's another kind of pillar of what we do is try to be multi-user, try to make the most capability and utility out of these investments, and enable more customers to come and use them. I'll just mention this pitch isn't really about UAS. I know that's another big strategic initiative for the Commonwealth. We have a dedicated airfield for UAS operations and have a steady customer set, including the Army, Hopkins, and SOCOM. So why do we do it all? Again, it's really cool to launch rockets, but the jobs and the economic development and the measurable impact that's having on the region, you can read here for yourself. The ones I like best, the prevailing wages for not just employees of the authority, but our customers, NASA, and the greater aerospace region that's impacted by the spaceport has 2 times the prevailing wage. And this study was done by the Draga Center at ODU a couple years ago, but showed a $2.9 return from every dollar appropriated to the authority. And that was just, through the headwinds of COVID at the same time too. So we never stopped. We kept sending food and supplies to the astronauts along the way, and we're only picking up the pace here. So I've said STEM a couple times. As the father of 7- and 9-year-old boys that have decorated my formal living room in Lego deco, mostly in space themes, I can tell you that talking about space and getting kids excited about rockets and exploration can really drive imagination. We have, part of our enabling language focuses on education. We have a dedicated educator that leads our educational department. And this is a strategic, purposeful initiative to drive the workforce and create the engineers and everything else of the future. We have a dedicated winter internship program that we've just established with William & Mary, which I wanted to mention here. We have multiple capstone projects. We want to get as many students through the spaceport to take advantage of the asset to inspire them for the future. I liken the spaceport, I'd like to see it be the Colonial Williamsburg of the future. When I grew up, everyone went to Colonial Williamsburg in 5th grade. That was like the dedicated, I grew up in Delaware, and that's where you went. I want that to be the spaceport. I want all of our students to come through there, get inspired, and go work and foster this industry. Oops. And yeah, I probably talked too much here, but just getting off the chart, getting off the stage here, this is an important thing for the Commonwealth. It's an important asset. It's a unique national asset for the nation, and it's been from purposeful investment. And I really think it's starting to drive and bring more and more customers. Every time you convince one rocket company to come and choose Virginia, it makes the next one that much easier. You create this virtuous cycle, and all the supply chain and everything can come through it. So that's why we think it's important to keep developing and growing that asset. So just contact information, and thank you for your attention. Aaron.
Thank you, Sean. Just a show of hands, how many people have been to Wallops? Oh, that's great. That's great. For those that haven't, you have an open invitation to come out anytime. Sean and I will give you a personal tour. We'll show you around and show you what we do. We're proud of it, and I can't say enough. You probably hear it in my voice. I'm super excited about what we do there. Sean did a really good overview of Wallops Island. We started together in 2009. I'm getting nervous here. We started together in 2009, and we started building the Antares rocket pad, which is now launched, I think, over 16 missions, I think. 16 missions. We resupplied the space station. So cool to stand on that launch pad, have the astronauts come back down and talk to us and say, thank you for bringing the supplies to us. That's what we bring to Wallops. That's what Wallops Island does for the community, for the space community in general. So really excited about it. I'm going to dive a little bit into Rocket Lab. I worked with Sean DeMello at Virginia Space for several years. I worked on the Antares program at Northrop Grumman, and I joined Rocket Lab 6 years ago. 6 years ago, we had a little slot of land that was just sand next to Pad 0A. In 11 months, less than a year, we had a functional working launch pad to launch Electron from. If that doesn't speak about how we can work as a community, as a partnership with Virginia Space and NASA, I don't know what does. That's pretty impressive in terms of space and what we can do. So I'm going to talk a little bit about Rocket Lab. This is a real high-level view of the company, but I'm going to try to dive into Wallops and what we do there and what we're bringing in the future. Wrong slide. Okay, so Rocket Lab overview. Our motto is open access to space to improve life on Earth. Pretty simple motto, and I think keeping it simple really helps us keep a clear, conscious vision of what we're doing and why we're doing it. And you'll see some of kind of that theme throughout the company profile here. So Rocket Lab started in 2006 with our CEO, Peter Beck. And in 2013, 2017 launched his first Electron rocket. And since then, as Sean mentioned, we just hit launch 53. So in that short of time, we've come a long way. Also in that path, we have become a publicly traded company. When that happened, we acquired a lot of industry manufacturers, and you'll kind of see the theme here again, that we want to be vertically integrated. We want to be able to kind of direct our own path and be in the control of our own destiny. That's what we bring to Wallops, and this is what you're gonna see that again. Again, I'll keep repeating it, but Rocket Lab at a glance. So there's 190 satellites on orbit that we've launched on Electron on those 53 missions. I won't go through all the numbers here, but pretty impressive for a small company that just started launching in 2013. You can kind of see that. Some of the pictures here, there's reactionary wheels. We developed those in-house. Those are a component that go on satellites and help steer the satellite once in orbit. Pretty unique piece that Rocket Lab supplies. The cool thing is we provide that to the industry. It's not just Rocket Lab. So we're also an industry partner in what we do. Our customers, as Sean mentioned, we're pretty strong with the government community here in U.S. NASA is a big partner in that. We've done a mission to the moon called Capstone. We launched an Electron rocket with a payload that went off to the moon and did some study there. We work with the NRO, we work with the U.S. Space Force, and you can see the variety of companies, Northrop Grumman, Lockheed Martin, a lot of big company names there that we support and continue to support in the future. Global footprint, again, this is kind of that profile with Rocket Lab, is we're spread across the United States now. And we have manufacturing facilities from Toronto all the way down to Long Beach. And all those entities support our mission in getting access to space. There's a big to market growth looking forward in the space future. So big numbers there. We're focusing day by day on that mission and slowly achieving and getting into that space. I think one important picture here in the lower left-hand picture is a picture of a satellite that now Rocket Lab has produced and flown for the company called Varda. This does pharmaceutical testing, did pharmaceutical testing successfully in that mission. It was not able to land on the time frame we expected, so it loitered in space for 8 months longer than we expected. Once we got the license to re-enter, we re-entered that spacecraft back in the desert, recovered it, and showed that we can successfully do pharmaceutical testing, grade testing, manufacturing in space. More of these missions are upcoming, and just really kind of highlights some of the things that Rocket Lab is bringing to the table. All right, so this is kind of the meat of what I wanted to get into. The Small Launch Electron. Electron rocket is 55 foot tall and 4 foot in diameter. It's a very small rocket in terms of rockets. We have 9 Rutherford engines at the base. They are 3D printed engines that are manufactured in Long Beach, California. And then the body of the rocket is made in Auckland, New Zealand. It's carbon fiber. And hopefully when you do your tour, when you guys take me up on my offer, you come up and I'll have one in the bay and we can take a look at it. It's like looking at a Lamborghini. It's beautiful. Everything has got its place, and we take a lot of pride in the perfection that we do. So hopefully that all happens and we can have you up and you can see this. Electron is the most successful new small rocket globally. So we'll talk a little bit more about that. I love this mosaic. This is not all of our missions because we've flown a few since this was made. But this gives you an idea of all these Electron rockets coming off the pad. And as Sean mentioned, we've had 4 of those come off the pad at Wallops, and many more in the future. Small Launch Leader, again, this is a little bit dated slide. We had 50 launches. We've done 53 to date. We have 3 launch pads. We have 2 in New Zealand, 1 in Wallops Island, soon to be 2 in Wallops Island, and we'll talk about that exciting news in a bit. And then I think the other thing that we bring to the table also just recently is hypersonic testing. We've taken the Electron rocket, we've modified it to do suborbital launches, which we've demonstrated now at Wallops, and support the government industry with hypersonics testing. And we're looking forward to that. That's a very bright future, and we add a great platform to that testing capability, all out of Wallops. This is probably one of my favorite pictures. This is the water tower at Pad 0A, and this is Electron. This is not any graphics, funny stuff. This is the real deal. This is Electron coming off LC2 pad with the water tower in the foreground.
It's not quite as close as you.
Yeah. Sean makes me stay safe, so we got to stay a little bit away. Yeah. But I love this picture. I think it really exemplifies what we're doing there and just shows, kind of the energy. It captures it in this picture of what we're doing. And unfortunately, the Mars logo is cut off, but this is all a partnership of Mars, Virginia Space, NASA, and Rocket Lab, all together making this happen in the cadence that we're looking at. This is the hypersonic that I mentioned. This rocket is called HASTE. It is driven from the Electron rocket, not to be confused. Will be modified for suborbital launches and supporting those tests. We're adding extra capacity on the payload fairing, so we can add more test materials underneath, and looking forward to that future again at Wallops. It is looking very bright. Won't go into much detail here, but we do have 2 launch pads in New Zealand, Mahia, New Zealand. We have, and both functioning. We did launch the NASA Capstone mission to the moon from New Zealand launch pad. And then again, there's a picture of the water tower and the Electron rocket there at Wallops in the corner. All right, so exciting news. We have really good success with Electron HASTE, and a few years ago, Peter Beck mentioned that we want to get into the mid-class rocket market. What does that mean? That means a big rocket. And in true Rocket Lab fashion, we're going to go after this, and we're going to go after it hard. We taking the composite industry that we've learned and composite knowledge that we've learned on Electron, and we're pushing that into Neutron. And we're kind of breaking barriers in terms of timelines to market and how fast we're developing this rocket. So that was mentioned a couple years ago. I think I have a slide here coming up. Our launch pad that I'm building with Sean at Wallops is well on track, and we'll be looking to launch Neutron from that pad next year. So just in a few years, you can see how fast we can move this with great partnerships here. So to give you an idea, what is Neutron? What are we talking about? Neutron is a mid-class rocket. So Electron, we can boast about 600 pounds to orbit. Neutron's going to take about 15 ton. So scale-wise, it's pretty big. It's going to be about 140 foot tall versus Electron, again, was 55 foot tall, so a much taller rocket. And the diameter goes from 4 foot to 21 foot. And the engines that we're producing for Neutron are called Archimedes. And those engines we're currently hot firing in Stennis, Mississippi right now. We're on our second serial number engine, second production engine. And those tests are going very well. So we're looking forward to flying those out of Wallops here very soon. Oops, I went too fast. Okay, so Neutron path to first flight. So when Peter Beck laid the challenge down to us, we started to have to set out our milestones as a company, how we're going to get there. And I think this chart just kind of attests to what we're after and what we're going for and how far we've come in a very short time. So the key one here is build the launch pad at Wallops, which we're heavily engaged in right now. And then again next year we're looking at our first flight there. This is kind of a cool picture of Neutron. So it's going to be a return to, eventually, it will be a return to launch site rocket. We're going to launch it, and eventually, and I say eventually, I got to prove that it's safe to Sean before he'll let me land it back at Wallops. So eventually, when I prove that to Sean, he says, "You're good," then I'm going to land it back at Wallops. So this rocket has a captive fairing. The fairing is the front section of the rocket that covers the payload or the satellites. The captive fairing opens, second stage is inside, and it gets pushed out. The fairings stay open, we glide back, we close the fairing, we light the engines, and we return to launch site. So we're bringing all this technology to Wallops very soon. And my invitation is still open. If you guys want to come to Wallops and watch this happen, we're going to be doing it next year. So I hope you can join us to see that. This is very exciting. So on the Neutron side, the vehicle development's well in way. We're leveraging a lot of what we learned from Electron and bringing that forward. This is, again, a carbon fiber rocket. So all the large components of the rocket are carbon fiber. So we're working on sections of that, and you can kind of see the second stage on the bottom picture. That's our second stage dome, propellant, basically propellant capsule. And then there's a pedal of the upper fairing on the top. I mentioned the engine, Archimedes engine, that we have developed in-house at Rocket Lab. We've 3D printed some of these parts and machined some of those parts, put those all together, and now we're testing those at Stennis, Mississippi. If you look at any of our Rocket Lab feeds, if you're interested about this, there's a really good compilation of all our test fires out there that are currently happening. All right, this is the meat. This is what I wanted to get to. This is what Sean and I do every day, scratch our heads on and try to figure out how to get here faster. This is our Neutron launch infrastructure, Pad 0D. Rocket Lab, we like to call it LC3, so you might hear that slip in once in a while. But we're pouring concrete, we're laying rebar every day, and we're getting this launch pad ready to support Neutron launch mid next year. So everything's well on way. We've got great support from the community, great support from the outlying construction companies. Can't say enough of how we're getting there. It's the support of everyone. It takes a team to get where we're at. This is our test infrastructure there at Stennis, Mississippi, with our engines, test bays. And then up in Baltimore, we have a facility we call it SSC, our Space Structures Complex. And we've just introduced the world's largest automatic fiber placement machine that will start spinning out Neutron parts. So that's the big block there, as you can kind of see on the left. It's really hard to see, but there's a bunch of spools of carbon fiber on the head of that. This machine will spin out parts of Neutron. We'll integrate those and then move those to Wallops, do final integration, and launch. And then also development partnerships with key U.S. government customers. So obviously there's a big interest in constellation missions now. Space Force has contracts out there for the NSSL program, there's a huge market there, so that's why we're heading in that direction. Space systems, I'll talk about this real quick, but you can see that Varda spacecraft in the background there. That's the capsule that we did the pharmaceutical testing on and landed back. We flew, actually that flew on a SpaceX mission, Transporter 8, and loitered for 8 months, and then we brought it back to Earth, and then looked at our test, and it worked. So a little bit about that. We have a motto: everything that goes to space should have a Rocket Lab logo on it, and we're working hard at that. So you can see the reactionary wheels that I mentioned earlier. The Varda spacecraft is another example. And then space applications, we do software, we do hardware, we do it all. So all that's in-house. And then the spacecraft family, I'm not real smart on these. I do mostly rocket launches on the ground, so I'll try here. We've come up with different classes. Explorer, Pioneer, Lightning, and Photon are the different classes of spacecraft that we build. And then at the end, I'll give a little surprise about what one of these is doing. Vertical integration, so what goes into the spacecraft is everything we make at Rocket Lab. Satellite radios, reactionary wheels, in-space propulsion, solar arrays, Sol Aero out of Albuquerque, New Mexico is part of Rocket Lab now. Star trackers, composite structures, flight software, and separation systems. They're all in-house and all within our company. And then owning the space supply chain, so we again work within our own company to get everything ordered and built together. I'll keep moving through these a little bit just to keep on time. And then we want to take on the world's most ambitious missions. So again, we're going to bring this to Wallops. This is going to be flying on Neutron very soon. So these are some of the missions that we've had components on. I think a lot of us have probably heard of these. The James Webb Space Telescope has solar arrays from Sol Aero. The Parker Solar Probe, the LADEE mission. So Sean mentioned a mission went to the moon from Wallops. The LADEE mission was that mission, and there was Rocket Lab components on that. Rocket Lab didn't exist at the time. That was part of the company we acquired called Sol Aero. ISS resupply, we've had components go there. The Mars Ingenuity helicopter has Rocket Lab components on it. And so you can see kind of the theme here. There's a lot we're going to get involved with and will be involved with. A lot of detail on this slide here, but these are all the different types of missions we're going after. I don't think there's anything left out there that we haven't touched or going to touch, so that's pretty exciting. And then this talks about the Varda mission. Won't go into more details about that. This is the last one I wanted to present here. We are building a spacecraft to go to Mars, so I think this is going to be a fun one to track with all those components and everything we're building in-house. And we'll be, I don't know where this one will be launching from, I'll be honest, but missions like this are very soon will be launching from Wallops Island in your own backyard. So we hope that you can take part of that and enjoy the spirit of rocketry and what we do and the exploration of space. So thank you.
Good afternoon. I'm Dawn Schaible. I am the acting director at NASA Langley Research Center, and I'm continually surprised by how often people don't know that there is a NASA facility right here in Hampton Roads. So I'm really excited to spend some time today and share with you the things that we do and how we are contributing to the nation and to the region. And I really was struck listening to the conference today by how much parallel NASA's story and this region's story is very similar. We are very much steeped in history. As was mentioned, Langley was the very first NASA center. It was also the birthplace of the space program for all of NASA. But yet, while we are very proud and appreciate that history, we are forward-looking and we're thinking about the future. So really glad to be here and to share all that with you today. So I just wanted to kind of set the stage of NASA as a whole and Langley specifically. There are 10 NASA centers across the country. That includes JPL, which is a federally funded research development center, but it's also really here in the Mid-Atlantic is a hub for NASA. We have as we mentioned, Langley Research Center in Hampton. We have Wallops facility, which is part of the Goddard Space Flight Center in Maryland, and then have NASA headquarters. So that really is a kind of a common location around this Mid-Atlantic region. But what is Langley specifically? So Langley has a workforce of close to 3,900 people within our civil servants and our on-site contractors, and always a constant flow of students coming through, located in Hampton. Have about 190 buildings and about 760 acres. And that is really made up of a lot of facilities, testing facilities, wind tunnels, as well as different research labs. Which you see the statistics on the bottom is that even though Langley is here, NASA does business with the Commonwealth of Virginia quite a bit. And so when we think about not only the work that's going on at Wallops, the work that's going on at Langley, but if you think about all the contractors and suppliers and vendors that help support all of NASA's mission, we really have a huge economic impact. Now, these numbers are from a few years ago. They're going to be updated here in a couple months, but I anticipate this number to continue to grow. So $2.5 billion in labor income and $6.8 billion in an economic impact and 32,000 jobs. And again, very much the same kind of story we heard about the need for those high-tech jobs, the need for the growing markets and the kind of work that we do and the impact that we do in the region. But actually more than that, we are proud to be a part of the community. And that's one thing about the Langley family. It's being part of this region and this Commonwealth is so important to us. And there's even more federal investment that happens here in the Commonwealth of Virginia. Over $200 million from the federal budget has been invested to revitalize the shoreline at Wallops and to replace the Wallops Bridge. So really glad to be part of this community. So as I mentioned, we have a very steep legacy. We were created in 1917, really just not long after aviation was created. And we were created as part of the National Advisory Committee on Aeronautics and was just going into around the time of World War I and the use of aviation as part of not only for commercial aircraft, but also in military applications, and the need to really understand how those aircraft operated, created NASA, what was Langley Field. And so what you see there at the very left at the top is the very first wind tunnel that was ever built at Langley in 1920. And a wind tunnel is just a way that you can test how different configurations, how different airplanes, how different rockets interact with the air around them and going through the atmosphere. So we became very proficient in understanding aeronautics and the way the atmospheres react to different things that you can do with airplanes and rockets. And that kind of understanding then also led to, again, as I said, the beginning of the space flight program, because overcoming those challenges of rockets going to the atmosphere, of going to the moon, All of that was done at Langley Research Center. But then as we got into the 70s, also realized that the atmosphere is also very important to us living here on Earth. Understanding our atmosphere, how we breathe, clean air, the effects that pollution have. So we grew a competency in understanding Earth science. And that's been really thriving and growing ever since as we understand that. And now we're expanding then to deeper into space and helping to understand how it is that we're going to go to the moon and go to Mars. So throughout that legacy of 107 years, there's sort of been a constant theme of curiosity, creativity, and innovation. And if I go back to the slides, I'll show you a little bit that kind of sums up what we do at NASA Langley.
At NASA Langley Research Center, what if isn't just a question. It's a challenge.
And liftoff. Here we go. Back to the moon and beyond.
It's we're wondering, what if we knew what's in the air we breathe becomes a cleaner planet for the next generation? We're wondering, what if we could make travel faster? Becomes a future where friends and family are never that far away. And we're wondering, what if we could explore deep space? Becomes the key to unlocking our universe's greatest mysteries. The future starts with a question. You just have to be bold enough to ask. At Langley Research Center, we put our curiosity and wonder to work, creating a better tomorrow simply because we dare to imagine it.
The impossible has become possible.
Our wonder changes the world.
Go ahead. So thank you. So what does that mean for us today? And I will talk about what we're doing to contribute to aeronautics, to exploration, and science. But there's a piece of this that can't be denied, and one of NASA's mission is to inspire the next generation. And the things that we do to inspire individuals to go into science and technology fields. That's pretty much the 5-year-old little girl that I was that was inspired by NASA to go into engineering, and that got me here today. So we work to do that because we talked about what does it take to build these technical fields and all that go with it, the business, our lawyers, our accountants, all that goes to helping NASA do their business. So when I talked about the 10 different NASA centers, each center sort of specializes in their own kind of capability that they contribute to all of NASA's missions and to the nation. And I'm going to talk at a really high level about NASA Langley because these are the things that are happening here in this region. Langley is known for its technology development, entry, descent, and landing. What does that mean? We saw the great pictures from Sean and from Aaron of rocket launches. So it takes, as you well know, a lot of energy to get off the Earth's surface and get through the atmosphere into outer space. But it also means there's a lot of energy that's going to have to take to slow us down, a lot of energy to dissipate to come back to the surface of the Earth. But there also is entry and technologies to help us land on other planetary bodies, whether it's Mars or Venus. Getting through all of those atmospheres, slowing down to have a nice, smooth landing. There was some number of years ago, maybe you all saw in the news when we landed the Mars rovers. They called it the 7 seconds of terror, right? That's because it's a very highly dynamic piece of the mission, and we're working on that. When you talk about structures and materials, we have to have different materials and different structure systems in order to explore the moon and to go on to Mars. We talked earlier today, I think when we were talking about the digital port, about how the bandwidth that we have for electrons back when we first started the internet to now, it's just growing. It's a little bit harder when we talk about that kind of bandwidth of getting things into space. Right now, because we have multiple rocket providers, that helps, but each rocket is limited to the amount of mass and the amount of weight that we can take, the size of any one thing that we can take into space. So we have to be creative. How can we actually build things in space? How can we make things lighter? So a lot of the work that's being done right here at Langley Research Center is around new composite structures, new assembly techniques that'll help us to do that. You know, the future, we talked a lot about this as well, autonomy, and what is the new, intelligent flight systems. We're, on a cusp of thinking about aviation to, more unmanned vehicles, more autonomous air systems. What is that going to do to our already congested air traffic space? How do we manage that? We're studying that. We're doing research. As I talked about with atmospheric characterization, really understanding what is in the air around us, how is that changing over time? How does external factors contribute to that? And then we've got to think about how do we put all this together for the future? What are some of these new concepts? What are the new ways to do this work? And then, our core is aerosciences. That again is the study of how the air, how the atmosphere moves around different structures. We do that with a lot with wind tunnels, and we have got 40 wind tunnels that will simulate that on the ground. But we have to take that data and turn that into analyses, simulation, and that is creating a need for very highly complex computer systems, a lot of data analysis, a lot of data-driven information, again, very much in line to what we talked about this morning as well. So I'll just focus on a few examples of things that we're doing in aeronautics. So one of the things that we are working on, and we've continued to work on, is try to make air flight faster, cheaper, and cleaner. And we have studied aircraft from when they were subsonic, supersonic, and now hypersonic. And one of the other technologies that we're working on is how do we actually make supersonic flight quieter? So you remember the Concorde, and you could get places very fast, but it was very loud. And how can we actually come up with, rather that being a sonic boom, a sonic thud? So that's some of the work that we're doing. We have a goal of net zero carbon emissions for our aircraft. How do we do that? Some of that is fuel efficiency. And you see there at the bottom, there was a new concept of an aircraft that'll make it 30% more fuel efficient. And then again, talking about the airspace and what it will look like with all these autonomous vehicles. In earth science, as I mentioned before, we're really studying the effect of climate change. We're studying what it means when we have contrails. What does that affect? What are the different aerosol levels? And again, trying to really understand what is driving a lot of our weather and working with others. And then finally, we have space exploration. And hopefully you've all heard of the Artemis program, which is the new program that is going to take us back to the moon, not only just to visit, but to stay, and use that as basically a proving ground to help us prove out and understand technologies that are needed for us to go to Mars. And at NASA Langley, we are doing a lot of testing of those vehicles that will go back to the moon and a lot of the different concepts that we need. We mentioned navigational Doppler LiDAR, which was on the first commercial lander. We also mentioned the advanced solar sail, the composite boom solar sail, which was actually launched by Rocket Labs from New Zealand. And that is actually flying right now. And it's using very large sail materials, like you would think of a sailboat, that actually catches photons to help propel a spacecraft in outer space. But what NASA Langley has done is built composite boom structure that can actually be deployed in space to help prove out that technology. So a lot of really interesting things that we're doing to move us forward. But we do all of this with partnerships, and I'm not going to spend a lot of time on this, but there's a few different ways here in which we partner. When I think about what NASA does and as part of being a government entity, it's really around the integration. We work very closely with universities that are doing that real cutting edge research, and we integrate that with the work that's going on in industry and the companies that can provide components and build spacecraft buses and build spacecraft. And then we're putting all that together to solve not only societal needs, but to help drive economic impact and really transfer that technology to industry that can use it in other ways that we might not have imagined. So it's really, to me, just a catalyst of growth in the economy and in understanding technology and in driving science forward and just our understanding. And like I said, I was inspired to come work for NASA when I was 5, and I'm inspired every day. I mean, NASA has, to me, the best mission statement. It's just exploring the unknown in air and space, innovating for the benefit of humanity, and inspiring the world through discovery. And we want to do that with our region, with you, our partners, to be on that path of exploration and inspiration. And with me here today, we have Lena Little and Kim Brush, and they're here to answer any questions on things that we can do together. We're proud to be part of this region, and we're proud to be members of this community. So I thank you for the opportunity today to share with you how our wonder changes the world. Thank you.
All right, so who's going to tell CNBC that Virginia is for launch lovers? That's what I want to know. I mean, this is just fascinating stuff. I'm so inspired by the 3 presentations, but particularly by the common thread of humanity, right? Leaving us on planet Earth better than you found us. So many questions, and I know there's not enough time. First question, and this is like jump ball, so anyone raise your hand first. What does 2020, this is 2024, and I've heard Pad 3 neutron launches, I've heard wonderful things coming up with supersonic thuds, right? I mean, so what does 2025 look like for us? What does it hold for us in Virginia from your vantage point for the space industry?
I'll take that one.
Sure.
Later this year, we have a couple HASTE missions coming out of Wallops. Next year, that cadence is going to pick up pretty significantly, and we'll be launching the Neutron rocket. As I mentioned, it's kind of a new innovative rocket that hopefully will shake up the industry and bring a lot of capability to Wallops, to Virginia.
All right.
2025 looks great.
Clearly. Okay. How about you, Sean?
Sure. Yeah, busy. We're going to have our 4th pad operational. We're going to have the new integration building that Aaron mentioned, where the neutron's going to be finally assembled and final manufacturing happening right outside of the gate. We have additional facilities we're in development for, and we're going to just continue to work on our manifest process and start getting really busy and launching more and more rockets out of the Commonwealth.
So for NASA as a whole, we're going to have a lot more launches, more science missions. We're going to get closer to launching the first crew to fly around the moon. But really, I would say for this region, one of the things that NASA Langley is really looking at is how do we take advantage of this region, whether that's within advanced manufacturing, autonomy, AI, space access. How do we work with our partners at Wallops and the Spaceport to not only look about what is that access to and from space look like, advanced manufacturing. We really want to leverage this region to help us accomplish the mission of NASA and building some of that partnership and some of those opportunities and being able to share the technology that we're creating at NASA Langley and NASA as a whole with this region to help as well.
So I heard you all talk respectively about STEM, right? Science, technology, engineering, and math. And the previous panel on the digital port, I believe President Williams, Hampton University, talked about the STEM infrastructure, the education infrastructure. What kind of credentials, what kind of talent are you all looking for people coming into your industry? Like, what kind of jobs are available, and what kind of capabilities do people need to have to get those jobs?
Yeah, I'll start. It's a really excellent question, and a lot of I'm not a rocket scientist, and we're running a spaceport, and the work that comes along with that takes a myriad of different types of backgrounds, from technical and engineers and logisticians, but lawyers and procurement and business development and project managers, and it's a really wide gamut of what we need to enable this industry, and that's why we've invested so much of our time and energy into the STEM focus, is so that, one, you can get the word out about that of course we're going to push STEM as much as you can, but there are jobs and opportunities and everything available for all types of backgrounds as we grow and manufacture, so I just want to make clear it's not just we're rocket science adjacent, but it takes all walks to get us there.
No, I would second that. Right there is every profession can find a home at NASA, but maybe thinking more broadly, when we talk STEM specifically, one of the things that has become a challenge, I think, and maybe this is a challenge too for our academic institutions that I know are tackling that, is that we're very much set up in our thinking, in our organizations, and in academic programs that are very discipline specific, right? Mechanical engineering, electrical engineering, biology. But the kinds of things that we are dealing with today and the advancements we had in technology are so interrelated and interdisciplinary. And so you see some of that, right? Biomedical engineering is a step into that. That's taking biology and engineering. Thermal and mechanical, is more interdisciplinary. So, getting more experience of working across boundaries, that really is needed to help us to solve some of these problems. I think what we'll have to see, we talked a lot about data science. It's a specialty now, but I think eventually that's part of what everybody has to know how to do, right? Because you're going to have to deal with that data within your discipline. So, I think that's one of the things that we'll work towards. But there is any kind of engineering, science, they're certainly needed to solve the problems that we have today.
And for Rocket Lab, I just echo the comments made. We look for everyone. It doesn't really matter. We have logistics, we have shipping, we have cleaning. We have every aspect you can think of to make it happen. So it's not as intense on engineering as one would think. We do have a panel of engineers that really work hard and design the launch pad and work on the rocket launch, but it's every supporting person that goes with it. And it's the can-do attitude also. We're a strong supporter of STEM. There's a Virginia Spaceflight Academy that's in the area at NASA Wallops. We're a strong supporter of that, and any function that we can get to, we have somebody from Rocket Lab there with Virginia Space. So I think we're a strong supporter of that. That's our future. We understand that. We support it. We embrace it. We want to grow it. So just comment all that.
Experiential learning, I think, is really important too. Getting kids access to know, again, what's out there. We're super excited about the Aerospace Lab School initiative and announcement that's coming forward for the Eastern Shore. Big supporters for that. And the Spaceflight Academy that Aaron mentioned, I don't know if you all know this, Virginia has a really excellent space camp, and but they do year-round STEM programming where they're able to get students early access to these types of programs to get that STEM pipeline growing. I'm on the board for that. It's an awesome opportunity. 11 to 16-year-olds can come up, march around on a spaceport, see rockets, and learn a lot over the summer.
Do the 16-year-olds have to come back? No, I'm just kidding. I know we have a couple of questions, so let me take some questions from the floor because I know I can ask a ton of questions. I think I see Ray White there. Hey, Ray.
Good afternoon. Hello. As former Director of Economic Development in the city of Hampton, thank you for all you do, Don. We worked a lot with you guys back in the day when I was there, dealing with your structure and materials expertise, and especially small businesses, SBIR programs. Can you give us an update of how those programs are going and how important today getting this technology in other industries is to NASA Langley? Thank you.
Yeah, so our small business programs are going very, very well, very strong. It is a critical component, I think, of what we do. Part of, being a government agency is around supporting the nation and in building that economic development. So much of our technology started out in small business incubators, and so I think it's going very well, and it's a critical component. I think I just read today we've met all of our goals and exceeded them, and so we're continuing to grow that. I really appreciate being a part of that.
Howdy. Question for Rocket Lab. So once your rockets are in space and you deploy satellites, is there a communications linkage somewhat akin to Starlinks/SpaceX?
I'm not sure I understand the question, but there is communication, yes. When a rocket takes off, for example, there's telemetry that the rocket sends, we receive, we monitor it through its mission. The other is we track its location through GPS for safety reasons. And then depending on what stage of the rocket we're looking at, first stage returns to Earth, second stage will usually return and burn up in the atmosphere before reentry. And then any other parts, depending on altitude, will burn up in space on atmosphere on reentry. So there's communications that constantly go through the whole process.
Right. So you don't you don't deploy satellites such as like an LEO or an MEO type of scenario?
Yeah, copy. So LEO, low Earth orbit, yes, we do. That's primarily where Electron lives in the orbital launches. So we do a variety. I think you saw all the customers we had. There's a variety of missions that they're trying to accomplish. Study of the Earth, study of the ocean movements. We did 2 missions for NASA, NASA Tropics, that now circulate the equator and look for hurricane activity and study that and give us pre-warnings of what weather impacts are coming. So it really varies on the customer and what we're after.
Gotcha. So one last question, I guess the combination between Rocket Lab and NASA. So if folks like SpaceX and Rocket Lab are deploying literally hundreds of satellites at some juncture, do we have to worry? I was just reading about, I don't know if you're familiar with the Kessler effect, whereby you could have some collisions in space, and by their own volition, it gets worse and worse. Can you have any comments on that, or how do you anticipate controlling that?
That's
Thank
a great
you.
question.
Sorry.
And it's a huge concern of ours, and it's being a good custodian of space. We're very cognizant of that, and we communicate that openly and freely to everyone and anyone, just so we don't have that scenario ever happen. But one of the charts I flipped through really quick had a whole bunch of activities that Rocket Lab is working on. One of those is capability, and I think we've launched for a customer that has the capability of going and looking at space debris and removing it. So that's one example. There's other examples that we can go into, but we're very cognizant of that, and it is, it's a real concern, and we're trying to be a very good custodian of space and what we do.
Yeah, I'll just add, NASA has recently undertaken a national strategy on space sustainability, for this being a part of that, working with other government agencies, working with our partners, looking at that more broadly in the sustainability of that what is becoming congested space.
And I'll just add one kind of spin on that, is that space is important, period, critical to our everyday lives. It's going to continue to be. And space situational awareness and how we, get and manage space is just jobs of the future, right? This space economy is going to continue to ripple out and grow as, rocket launching becomes more mundane and we start exploring and the logistics and interplanetary type things happen. How that ecosystem, that marketplace, that's, again, I keep saying, like, launching rockets is cool, but it's everything that comes along with it is why we're here. So it is definitely a challenge, but I think it's also an opportunity for the future of investment in commercial markets. Thanks.
I think Rick Dyer has a question.
Hi, Rick Dwyer, Hantrose Military and Federal Facilities Alliance. Thanks for being here today and talking to everybody here about the unique assets that we have right here in the Commonwealth with Wallops and NASA Langley. Also, potentially here off the coast of Virginia, we have the potential for offshore wind industry to grow. Can you all talk about any concerns that you may have about potential conflicts or impact of offshore wind to rocket launch operations, unmanned systems, hypersonic testings?
Yeah, I can't talk a lot about it, but I'll say that we and NASA Wallops, who owns the range for actually launching the rockets, have been in conversation with BOEM and I can't remember the acronym for some of the Virginia-specific people that are out developing the wind farms. We're all for the development of it. We think there's a solution that the assets and the wind farms can be developed in Congress with each other and such that we don't see it as an inhibitor. That there are similar types of challenges that happen on the West Coast out of launches from Vandenberg with platforms out there. It can be solved, and we, as rockets get safer, as safety rings get smaller, we're going to be okay. And so we're all for again, future development and cleaner energy.
I just wanted to ask, who is the competition for Wallops Island? Is there competition out there, or who are we going against?
That's a good question, Elon. No, I mentioned earlier we're one of 2 East Coast launch locations currently licensed, and Cape Canaveral, Florida, which is a Space Force range, and Kennedy Space Center, all co-located, and the bulk of launching is happening out of Florida. But we're the only other place to do that. And I mentioned it earlier, when you're launching equatorially, so we launch between kind of 38 and 60 degrees, that you can't do that from the West Coast without taking a lot of energy hits from the way the Earth spins. So, but in terms of competition, we have an excellent relationship with the Space Force, with NASA. Cape Canaveral is getting really busy as more and more launches happen. We see ourselves as a backup and an opportunity for growth for more of those small and medium class launches to grow into. So, of course, when I convinced Aaron and Rocket Lab and we did to come to the Commonwealth in 2018, that was a huge win. And we're going to continue to go and try to pursue those type of commercial companies to choose Virginia, where they're going to not only launch from, but manufacture as well. So there's always that to it, but we very much see and are entwined inside of this larger space economy. There are many launches coming. We want to do that as efficiently as a nation as we can.
So Stephen Edwards of the Port, so you can return the question in a moment. But this is a question for Aaron. So Aaron, when you did your presentation, you talked about a lot of 3D printing in California and manufacturing elsewhere. So what do you need to bring that to Virginia?
That's a great question. Right now we're focused on launching the rockets from Virginia. I think inherently some of that will come with that as we develop and grow and get more launches. So I think that's part of just the growth of what we look at Wallops. That also, if you look at the future, that brings satellites, that brings customers, that brings other customers, that brings commercial companies. It's kind of a cascading chain of, I see a lot of growth coming with all of that. And I think that's what's going to bring it to Virginia. The headquarters, there's a space sector there in Long Beach that has a rich history of a lot of talented rocket engineers and rocket companies. That's hard to compete with, but I think what we bring is we bring the fire end of it. We launch them, and they can come join us, is the way I look at it. A little bit cavalier, but let's go. I enjoy what we do, and I think that's where the energy's at. That's where we can bring a lot to Virginia that way with the companies that support all of that industry.
And then for our final question, because I know we're running out of time. Oh, Milan. All right, Milan.
Milan, right here. My question is, so about 3 months ago, I had a nice conversation with the NASA OSDBU, Office of Small Business Utilization, and Mr. Mann told me our main concern is to keep our astronauts safe in space coming back. And the second thing he said that's interesting to me, and I've been thinking about it, is that he said that the supply chain in Virginia for serving the industry, a lot of them are out of state, meaning they are not in Virginia. That's one question. Second question, I just want to ask you, how is your workforce? With all the very high level of skills, have you been using the talents? And do you have enough people to serve the industry? But my interest is the supply chain in Virginia. Do you have a directory of Virginia companies that serve that industry for some of my members in this room that may want to do business with NASA? Thank you.
So we can get that. My team here will get that, of the known suppliers, absolutely. There is a large number of the supply chain is in Virginia, but I think to your point, there's others that aren't, and certainly an opportunity to see more of that in Virginia, but we can certainly provide that to you. NASA is a draw, so we get a lot of applicants, but there are a lot of specialized skills that, like we heard earlier, it is sometimes difficult, but always have opportunities for folks to come work at NASA in a lot of the specialized areas. And my goal, my hope is that as we continue to flourish and this region flourishes, there's more opportunities, even if it's not with NASA, it's within our partners, that we see that space economy. There'll be a lot of opportunities for, space economy type jobs.
Well, Dawn, Aaron, and Sean, thank you very much. Let's give them a round of applause. And I think as an economic matter, when we talk about site readiness in our Commonwealth, we need to start thinking about rocket launches and rocket returns. Thanks, everybody.